Okay, so let's talk about what makes this unit circle so special. So if we're looking at these angles, I have several angles over here. Let's first look at 60 degrees, which is the same as our pi over 3. So when we did our pi over 3 radians, we found that it wrapped to this point 1/2 comma square root of 3 over 2. And so that we know that that's 60 degrees. Now we can look at this. What makes this unit circle so special is this radius of 1 is going to really help us with our trigonometric functions. Because we know if we look at 60 and we look at the sine of 60 and the cosine of 60, that's going to give us some values. So first let's look at the cosine of 60. So cosine of 60 is going to be adjacent over hypotenuse. Well, hypotenuse happens to be 1. So it's really just going to be, cosine of 60 is going to just be 1/2. 1/2 over 1 is just 1/2. So cosine of 60 is the x coordinate here. So this 1/2, cosine of 60 is 1/2, is the x coordinate of this point that it mapped to. So then if we look at the sine of 60 degrees, that's the opposite over hypotenuse. Now the opposite is rad 3 over 2 over 1, and that unit circle makes it so this part of the coordinate point is actually sine of 60 degrees. So when I want to find cosine of 60 degrees, all I have to do is go over here to 60 degrees, and I have to find what the x coordinate is, which is 1/2. And here, if I want to find the sine of 60 degrees, I go over here to where 60 degrees is, and I find the y coordinate, rad 3 over 2. So I could also write this in terms of radians, where I have cosine of pi over 3, sine of pi over 3. So if someone asks you the cosine of pi over 3, you can use the unit circle to find its value. You just go over here to pi over 3 and you look for the x coordinate. And if you wanted sine of pi over 3, you're just looking for that y coordinate in your unit circle. So then let's look at this. So if we have over here, we've got this angle, and this angle goes all the way over here. So this arc length is 3 pi over 4. 3 pi over 4, this whole section right here, that's 90 degrees plus another 45 degrees. So that's going to be 135 degrees. So if I want the cosine of 135 degrees, I know it's going to be this adjacent over the hypotenuse. The hypotenuse is 1, and this is 1 over rad 2. So I know that negative square root of 2 over 2 comma square root of 2 over 2, the x and y coordinates here are going to give me the cosine and sine of these values. And I could also say cosine of 3 pi over 4. I go over to 3 pi over 4. I know my values over there. I don't have them written, but my point values are rad 2 over 2, which is just 1 over the square root of 2 rationalized, and my x value is negative. So my cosine of 3 pi over 4 is going to be negative square root of 2 over 2. Sine of 3 pi over 4 is going to be positive square root of 2 over 2. And I can find those just using my unit circle. So then if we look at 150 degrees, go all the way over here, look at 150 degrees, I've come down to 7 pi over 6. 7 pi over 6. I can look at my values. So this one's going to represent my cosine of 7 pi over 6, and this will represent my sine of 7 pi over 6. Or we can think of it in terms of it's not 180 degrees here. Let me just fix that. 150 degrees. Okay, so that's 180 degrees plus 30 degrees, which is going to be 210 degrees. This is 210 degrees. So 210 degrees is equivalent to 7 pi over 6. So when I'm looking at that, I can say the cosine of 210 degrees, I can go over here to 210 degrees, and I can look at that coordinate point that's corresponding with that. And I can say the cosine is just of 210 degrees is negative 3 pi over 2. And I can do the same thing with my radian measures, my 7 pi over 6. So the cosine of 7 pi over 6 is just going to be that x coordinate. So if it's a unit circle, and that's important because otherwise the radius isn't 1 and it doesn't work out like that. If it's a unit circle, the cosine of whatever you're talking about, the cosine of the angle, is going to be your x value of the point that it wraps to. And the sine of theta is going to be your y value. So let's take a look at how that works in our circle. So cosine of theta equals x, sine of theta is equal to y. So the sine of 5 pi over 4, so I just go over here to 5 pi over 4, which is down here. And if I want the sine of 5 pi over 4, I'm looking at my y coordinate. So that's just negative rad 2 over 2. Cosine of 2 pi, that's all the way around here, goes right here. Cosine represents my x coordinate, and that's just 1. Sine of 30 degrees. So when I go to 30 degrees, that's the same as pi over 6. So that's my 30 degrees right there. I go to pi over 6, and I want the sine of 30 degrees, so I want the y coordinate, which is just 1/2. Now if you type this in on your calculator, you're going to get 0.5. The reason you don't want to always use your calculator is you're going to get estimated values if you have a radical. Cosine of 270 degrees, this is 180 degrees plus another 90 degrees, this is 270 degrees. Cosine is my x value, which is just a 0, so cosine of 270 degrees equals 0. Sine of negative pi over 4, I'm going to go back pi over 4, so it's going to be right here. And my sine is going to be negative, in this case, it's going to be my y coordinate, so that's negative rad 2 over 2, or if you didn't rationalize, 1 over rad 2, negative 1 over rad 2. Cosine of 4 pi over 3, I'm just going to go around, this is 3 pi over 3, and then 4 pi over 3 is right here, and I'm looking at the cosine, so I'm looking at the x value, so that's just negative 1/2. Sine of pi, go over here to pi, look at my y value, which is just 0. Cosine of pi is my x value, so this should be negative, I'll write that a little bit bigger, negative 1. So that's how the unit circle works. If you want to look at tangent, tangent is going to be, let me bring this back up a little bit. Tangent of any of these is always going to be the opposite over the adjacent. So the opposite over adjacent, this is my y value and this is my x value. So if I want to find the tangent, tangent of 60 degrees, I take this value over this value to get my tangent.